Welcome everyone. Today we will discuss natural convection between two non-isothermal vertical parallel plates. My name is Muhammad Uzair. Let's move to the problem definition. Determine the steady temperature, density and velocity profiles by natural convection between two non-isothermal vertical parallel plates separated by a distance of 2d by using ANSYS Fluent. Assume both plates are at constant temperature of 340 Kelvin and 320 Kelvin. Compare results for 10, 50 and 100 nodes or divisions. Now here we will have to develop temperature, density and velocity profiles by natural convection between two non-isothermal plates in which one plate is at a temperature of 340 Kelvin while the other one is at a temperature of 320 Kelvin. So we can say that one is a cold plate while the other one is a hot plate. We will simulate this problem in ANSYS Fluent, and at the end we will compare the results for all three profiles for 10, 50 and 100 nodes or divisions. So let's start by simulation of the problem in ANSYS. This is the ANSYS Fluent interface. Double click on the Fluid Flow Fluent. Now step 1 is specifying the geometry. Now again in the ANSYS Fluent interface, double click on the geometry option. Now it's a 2D problem, so now here select the XY plane, click on the XY plane and turn it into XY direction. Okay, now after that, first of all click on the sketching tab and draw a rectangle. Now again moving to the click on dimensions tab and specify dimensions. So click on this one and again click on this one. These are the horizontal dimensions and these are the vertical dimensions. As you can see, h1 is representing here the horizontal dimension while v1 is v3 is representing the vertical dimensions. Now first of all go to the units option and select the units in centimeter. The horizontal dimensions, let the horizontal dimensions be 2 centimeter. The distance between the plates be 2 centimeter. While the plates are in the vertical direction, they are 20 centimeter high. Now after that, click on fit to window, zoom. This is our surface. This is our sketch we have drawn. Now move to the concept option and select surfaces from sketches. Select the sketch and rename this. Let's rename this surface as surface 1 and apply. Click on apply, and after that click on the generate tab, and as a result you can see a surface is generated. Now select the edge option and then right click on this edge and rename it as C plate. Means the cold plate, and click on the generate tab. After that move to the second edge, right click on this one and rename the selection as H plate, the hot plate, and click on generate tab. Again, repeat the same procedure for the third edge and name it as W1, wall 1, and click on the Generate tab. After that, select the fourth option, the fourth edge, and rename it as the W2, means wall 2. Now here we are considering that, and click on the Generate tab before moving to the next thing. That is, now here we are considering that the fluid is in between these plates. Nothing is coming into and nothing is going out of the plates. So here we have specified the geometry completely. So step 1 is finished here. Now moving to the step 2, which is generate mesh for the geometry. So let's do step 2. Again, coming to the ANSYS Fluent interface, right click on the mesh tab and click on edit. Now click on this one. This is our geometry in XY plane. Now right click on the mesh option and insert sizing. Now again click on the edge selecting option and select this edge, control plus select this edge. For selecting two edges at a time, use control, first edge, then control, then plus control, then the second edge. Now apply, click on apply, and here in the type convert it into number of divisions. Now we have to enter here the number of divisions. Now in the first case we are doing it for 10 divisions, for 10 nodes or divisions. There are 10 nodes or divisions between the two plates. Okay, 10 and enter. Then the behavior should be hard. Again, now again right click on the mesh option, insert again sizing. Now again click on the edge selecting option, select this edge, control plus select this edge and click on apply. Again select the number of divisions in the type option. Now as previously the horizontal dimensions were 2 cm while the vertical dimensions were 20 cm, means it was 10 times of the horizontal dimensions. I'm talking about the vertical dimensions. It was 10 times of the horizontal dimensions. So here the number of nodes in the previously what we were defining were the nodes between the vertical and between the those were the vertical nodes basically, which were between the cold plate and the hot plate. But now we are defining the horizontal nodes and it should be in the vertical direction, so they should be 10 times of the horizontal nodes of the nodes in the moving in the horizontal direction. So previously we entered what 10, so 10 multiplied by 10 would be 100. Again select the behavior as hard. Now click on the generate mesh tab for generating the mesh. Now click on the mesh option. As you can see, the mesh is generated. Let me show you. As you can see, the mesh is generated, but the mesh is quite an irregular mesh. As you can see, it's a very irregular mesh. Now to convert this into a regular mesh, again right click on the mesh option and insert face meshing. Face meshing is a solution to convert irregular meshes into a fine and regular mesh. So for face meshing, select this surface and click on apply. Now again click on the generate mesh tab and it will generate a regular and proper mesh. Now click again on the mesh tab. Now as you can see, a regular and proper mesh is generated this time. It's a proper and regular mesh, a fine mesh. Now here the second step is completed, which was generating the mesh for the geometry. Again, coming to the ANSYS Fluent interface, again right click on the mesh option and click on update. As you can see, the mesh is updated now. Now moving towards step 3, which is basically specifying the conditions and models in the setup option. So let's move to the setup option in the ANSYS Fluent. Now moving towards step 3, which is basically specify the conditions and models in the setup. So let's move to the setup option in the ANSYS Fluent interface to specify the conditions and models. So again, coming to the ANSYS Fluent interface, right click on the setup option and click on edit. Now select the double precision option and click on OK. Now this is the setup interface. Now first of all, there is a general option. Now here we don't have to change anything. All the things are according to our requirement. Time is steady, pressure based, type is pressure based, and we just have to change for one thing, that is for natural convection we have to involve gravity, and that is in the negative y direction, obviously minus 9.81. Enter, and then let's move to the models option. We have to involve the energy equation, because for natural equation, energy equation should be involved to develop the temperature profiles and density profiles as well. So double click on the energy option, select the energy option, energy equation option, and click OK. So energy equation is on now. Now moving to the materials option, here we will select the fluid. In our case, it is air. And as you can see, by default air is selected. Now moving to the properties of air, density. Now in this case, density shouldn't be constant. Select incompressible ideal gas and click on change create, and then again close. Then after that, move to the boundary conditions, cell zone conditions, double click on the surface body, select air, obviously. So here as you can see, it is by default air is selected because it's the only fluid here. So again click on OK. Now moving to the boundary conditions, first of all double click on the cold plate. Now as you can see, it's a stationary wall and no slip boundary condition. Now click on the thermal tab, select temperature, because the only known thing here is the temperature of the cold plate, and that is 320 Kelvin. Okay, and then double click on the hot plate. Again, it's a stationary wall, no slip boundary condition. In case of momentum equation, click on thermal tab, and here we also know the temperature, that is 340 Kelvin. Enter, and then OK. Now click on wall 1, double click on wall 1. Now it's again a stationary wall, no slip boundary condition, and we don't have to involve anything in this one. It's only a simple wall. OK. Click OK. Again, same is the case for wall 2 as well. No slip boundary condition and stationary wall. OK. Now moving to the solution methods. These are the methods. These methods will be chosen by the system for solving any particular case. For our case, the system has chosen the simple scheme. For the gradient, least square cell based, pressure will be second order, momentum equation will be second order upwind, and energy will be second order upwind as well. Now moving to the monitors, here double click on the residuals and change these values to 0 from 0.001 to 0.000001, or you can say that penta 01. Again, do the same for this one and click OK. Now moving to the solution initialization, change the settings from hybrid initialization to standard initialization and compute from all zones. Click on initialize and then move to the run calculation option. Enter the number of iterations you can enter. So here you can enter any random number of iterations. Okay, let's enter 1000 iterations. Click on calculate. Okay, the application is busy. We can wait for a moment. Then again click on calculate. As you can see, calculating the solution. So let's wait for the software to calculate the solution. So the calculation is complete, and as you can see, the solution is converged in 303 iterations. 303 iterations. Now click OK. Now here step 3 is completed, in which we have entered all the models and conditions. We have entered all the conditions in the setup to solve the solution. Now moving to step 4, plotting temperature, density and velocity profiles. Now again, coming to the setup option, to the setup interface, go to the graphics option, double click on the contours, select the filled option and contours of temperature, click on compute and display. As you can see, these are the temperature profiles showing the temperature contours from 320 to 340. Let me show you. As you can see, now for the velocity profile, click on the velocity contours and compute. Again, click on display. These are the velocity contours. Let me show you. Now click on this again. Now close these things. Now double click on the vectors velocity vectors, compute, and click on display. Now these are the velocity vectors. Let me show you by zooming in. As you can see, the vectors near to the hot plate are going up, while the vectors near to the cold plate are going down. While this is basically a transition, a different region between this. Here it is going up, while here it is going down. This is the mid portion of the plate, between the plates. Now, close this option, move to the plots option, double click on XY plot. Here, generate a new line. The range will be, obviously previously, here the units are in meters, and the horizontal, in our case, the horizontal direction length is 2 centimeter. So in meters, it will be 0 to 0.02 meter. While for the y direction, here select the mid portion between the plates. The total length of the in the vertical direction is it's 20 centimeter, and in meters it will be 0.2 meters. But here we are basically interested to find the profiles in between the plates. So here the initial length will be 0.1, while the final will be 0.1 as well. Now click on create. A line will be created here. As you can see, line 5, click on close, select this line for temperature and click on plot. Now here we cannot see the proper profile because it's only showing some points. Now click on curves option. Here select the pattern, select the color for the line, let it be black, the weight of the line let it be 3. Now moving to the marker style, let it be the same. Let it be black and set it to be 0.6. Now click on apply, close, click on plot. Now as you can see, this is the temperature profile. Now we can clearly see this temperature profile. It is showing simply an increase, a linear increase, a proper, not a very linear increase, because in case of 10 nodes we won't get fine results. But as we move to 50 nodes and 100 nodes, the profile will change to linear, will convert to a linear profile, because the mesh will be finer in that case, and the results will be accurate and better. So that's why we move to 50 and 100 nodes later on. Now let's check the density profile. This is the density profile. It's showing a decrease. For the velocity profile, select the velocity, and we are interested to see the velocity in the y direction, in the direction of increasing length of the plates. Now again click on plot. This is the velocity profile. As I told you earlier, that the velocity vectors are going down, which are near to the cold plate, while the velocity vectors close to the hot plate are going up. That's why this is the exact profile. Now we'll export the data of these profiles for density, velocity, and temperature to export the data of these files as files, and we will use that data to plot the profiles in an external software. Now for that, Now we will export the data of velocity, temperature, and density profiles in, in different files, and then we will export that data to an external software for plotting the files in that software. Now for that, first of all, this for velocity, select here write to file and click on write. And let's name it as V for 10 nodes or 10 divisions. Okay, a file is generated for the velocity profiles data. Now here select the temperature option and write a file for the temperature data. Name it as T10. And for the density profiles, again here click on the write to file option and name it as P10. Now close the file. Now each and everything is completed at this stage. Now we will repeat the same procedure by moving to step 5, which is compare results for 10, 50 and 100 nodes divisions. We have plotted and we have generated results for 10 nodes divisions. The remaining ones are 50 and 100. So let's move and repeat the same procedure for 50 and 100 nodes or divisions. Again, coming to the setup interface. Now for generating the profiles for 50 and 100 nodes, we just have each and every settings should be the same. We just have to change the mesh size. So let's move to the mesh generating interface. So now here we are in the mesh interface. Here click on the select the edge sizing number 1, which was 10 nodes, 10 divisions. The number of divisions were 10. Here change it to 50, and for edge sizing 2, it was 10 times of the nodes or divisions which we have to incorporate for the hot between the hot and cold plates. So for 50 nodes and or divisions, for 50 divisions, it should be 10 times of 50. That will be obviously 500. Enter. Now click on the generate mesh tab. Now click on the mesh tab, mesh option. Face meshing is already done, as you can see. Now let me show you the new mesh. As you can see, this is a regular and proper mesh. Okay, now let's move to the ANSYS interface. This is the ANSYS interface. Click on the mesh tab, right click on the mesh tab and click on update. Again the mesh is updated. Now let's move to the setup. Now here we are in the setup interface. Here as you can see, it is asking that. Now here we are again in the setup interface. Upstream mesh has changed. Would you like to update the input data before proceeding? It is asking that. So click on OK. Now here, as you can see, the mesh is updated. We don't have to change anything here. The only thing we have to change is initializing the solution. Each and everything, all the settings, all the models, all the conditions will remain the same. We just have to initialize the solution again. Compute from all zones and click on initialize. After that, move to the run calculation option, and again the random number of calculations in this case will be the same. Let it be the same and click on calculate. And as you can see, it has started to calculate the solution. It is calculating the solution. Let's wait for it to calculate the solution completely. Now this is the density contour for 50 divisions. For temperature, compute and display, this is the temperature contour. Now for velocity, this is the velocity contour. Now here, double click on the vectors to see the velocity vectors. Velocity, compute and display. These are the velocity vectors for 50 divisions. Let me show you again. As you can see, the vectors near to the hot plate are going up, while the vectors close to the cold plate are going down, while this is basically the mid zone between the plates. It's going up and down, and this is basically the transition region between the two vector phases. Now let's see the profiles. Double click on the plot, double click on XY plot, and select velocity for line 5. Let's change the settings for the line again to 3 and 0.6. Black, apply and close. Plot. Now we are interested in the y velocity, so this is the velocity profile. Okay, there is some mistake in the color. Black, apply, close. Let's plot the line. This is the velocity profile. Now again we will export the data for temperature, velocity and density profiles to the for plotting in the external software. This is the temperature profile, and this is the density profile. Now let's export the data. Write to file, select the write to file option, write a file for this, name it as P50. For temperature, again write a file, name it as T50, and for velocity, y velocity, write V50. Now we will plot this data in the external software. Now again we will repeat the same procedure for 100 divisions. Now let's repeat the procedure by changing the mesh and convert it to for 100 divisions or nodes. Now again, coming to the mesh interface, click on the mesh option, go to the edge sizing, change here the number of nodes from 50 to 100, and again here obviously it will be 10 multiplied by 100, so because it's 10 times more than the 10 times more than 100, so it will be 1000. Again, face meshing is already done, so we don't have to go in that. Click on the generate mesh tab, and as a result of which mesh will be generated for 100 divisions. Now let's go to the mesh. As you can see, mesh is generated. Let me show you. This is the mesh. As you can see, it's a regular 100 for 100 divisions grid. It's a regular mesh. Fit to window. Let's move to the ANSYS interface now. Now here in the ANSYS interface, right click on the mesh option. Click on update. And as you can see, the mesh is updated. Now let's move to the setup option. Now this is the setup interface, and it is asking that upstream mesh has changed. Would you like to update? Obviously we would like to update it. It's updating the mesh now, and it has loaded the new mesh. Now we don't have to do anything, just we have to initialize the solution again for this new mesh from all zones. Initialize and run the calculation again. Now let's plot the profiles for 100 nodes, 100 divisions. Okay, now for this line, okay, previously we have selected the write to file option. Let's unselect it. Now plot. Let me again, it's changed. So obviously we have to do the same procedure again. The black, set it to 3.6, black, apply, close, plot. Okay, now let's export the data for this as well. Same to plot the temperature, density and velocity profiles for 100 divisions as well. Name it as T100. Okay, for density, let's name it as P100, and for velocity, again let's write the file and name it as V100. Now here we have plotted and we have done all the work in ANSYS. Now let's compare the results of 10, 50 and 100 nodes and divisions in the external software, which will be Excel in our case. Now these are all the exported files. P10, P50 and P100 are for densities. All the T files are for temperature, and all the P files are for velocities, which we exported from ANSYS. Now let me show you. Double click on this file, and we can open this file using Notepad. This is the data for X and Y axis. These are the densities and these are the X values. The horizontal direction variation from 0 to 0.02 meter. We can copy this data and to Excel and this data can be used to plot the density profiles. Also, the same procedure will be for all the other files. Now let's move to the Excel files to plot the density, velocity and temperature profiles. Now this is the Excel file which I've created. Now these are the data for 10 divisions, for 50 and 100 divisions, for density, and based on this data, these are the density profiles. As you can see, all are showing linear decrease, somehow a linear decrease, not a completely linear decrease. Now if we plot all these profiles on a single profile, on a single graph, this we will get something like this. Now here the red lines are for, the red line is showing for 100 divisions, while for the blue line is for 50 divisions, and the green line is for 10 divisions. As you can see, the blue, all the three lines are coinciding with each other, but the results are obviously the better and accurate for 100 divisions. That's also there is quite a small decrease, a small difference basically between 100 and 50 divisions, while as you can see 50 and 100 divisions are coinciding with each other completely, while for 10 divisions, this is, which is this green line, it is deviating from the other two, because for 10 divisions the results are not that much accurate. Now let's move to the temperature profiles. This is the data for the temperature profiles for 10, 50 and 100 divisions, and these are the profiles for 10, 50, and this is for 100 division. If you plot these profiles on a single graph, we will get a result like this. Now here, let me show you. All the three are somehow coinciding with each other, but here for green line is for 100 divisions, 10 divisions, the red line is for 50, and the orange line is for 100 divisions. As you can see, all the three are somehow coinciding with each other, but here from the results you can see that the green line is somehow deviating from the other two. Somehow there is a difference. The 100 line is giving the more accurate results. These are the more accurate results. The red line, which is for 50 divisions, is somehow there is a very little difference between the 100 divisions and 50 divisions profile, but there is somehow a larger, or you can say that a greater difference for 10 divisions from the 50 and 100 divisions, which was previously the same case with the density profiles. Now let's move to the velocity profiles section. This is the data for velocity profiles for 10, 50 and 100 divisions. The profiles based on this data are these. If you plot these profile for 10 division, this is for 50 and this is for 100 divisions, you can say that their trend is quite same. But if we plot them on a same graph, this is what we get. Now here, let me show you. The red line is showing for 100 divisions, the blue is for 50, and the green again is for 10 divisions. As you can see, and obviously the red line is showing the better results, the accurate results. While the other two, in this case, are deviating from the red line. Even for the 50 divisions, the results are not that much accurate, but as you can see here, the blue line is for 50, while the green line is even deviating more. There is even a difference of 10 and 50 divisions. The deviation from 100 divisions is more for 10 divisions. The 10 divisions curve is deviating more from the 100 divisions line, while for the 50 divisions profile is deviating lesser as compared to the 10 divisions line, is deviating not that much as compared to the 10 divisions profile. Let me show you from a closer view. Let's zoom in. This is for the 100 divisions. Again, the blue line is closer, much closer as compared to the green line to the red line. There's a difference. The difference between blue and red line is less as compared to the green and red line. That's what I meant to show and explain here. So the results what we get is that obviously as the number of divisions and nodes increases, the results will get better, will get more accurate and better results. While for 50 divisions, the results will be you can say that the second priority for better results will be 50 divisions, and obviously the last priority will be 10 divisions. which are the results in the case of 10 divisions will not be that much accurate as compared to the other two cases. So that's all.